For this problem, we're asked to solve for x. Now, the first thing you'll be tempted to do if you just started learning algebra is you'll take it and you'll try to isolate x. Now, we know that that's not going to work, but I could show you that it's definitely not going to work. Let's see what happens if we try to isolate x. In this case, if we have an x squared term here and an x to the power 1 term. This is actually a quadratic equation. So let me just write that there so you can quadratic equation. Okay, so because this is a quadratic equation, if we try to isolate x, so let's try to do that. If we get all the x's to the one side, we'll have x squared minus 13x is equal to minus 45. Okay, so can we find a value for x now which would make this equation true? Well, I think that would use a lot of trial and error and it would be quite difficult. But what we could do to solve this equation, instead of having two x's on this side and actually not knowing how to isolate one x, because these terms are entirely different, what we can do is we can actually use what we know about factors. So let's go a little bit into some of the background information to this that I'd like you to keep in mind when we do this problem. So if I have a and I multiply it by b, and I want an answer of 0. If a is 0 and b is anything, the answer is 0. Or if a is anything and b is 0, our answer is 0. Okay, so we can keep that in mind. We can also keep in mind from what we know previously, if you have a times b, that's the same as saying length times breadth for a rectangle. Now, if you recall from when we did factorization, what we did was we took something in the form of this, in a quadratic form, and we turned it into two factors, length and breadth. Now, if you have a length times a breadth that equals to 0, but this length times this breadth, and the area would be 0, we could say that if we take a trinomial, so this, if you take a trinomial and you factorize it so that it has two factors that equal to 0, then if either one of these factors are 0, this statement over here would be true, or the value for x would be correct. So let's see, this seems very abstract, so let's actually put it in an example. So what I'm going to do is I'm going to try and put this in the form of two brackets multiplied by each other to equal to 0. So let's have a look there. What I first want to do is I want the right hand side to equal 0, because then I'll have a trinomial I can factorize on the left hand side. So how will I make the right hand side here equal to 0? Well, that's pretty simple. So x squared minus 13x plus 45 is equal to 0. I've just added 15 to both sides to make the right hand side 0, and this equation still holds true. So what I'm going to do is I'm going to factorize this trinomial. How do I factorize this trinomial? I find factors, I multiply the coefficient of the first term with my last term, and I'll get, let me do it up here, I'll get 45. Now what are my factors of 45 that can add to give me negative 13? Well, if I take minus 6 and I add it to minus 7, that will give me minus 13. So, to factorize here, I'll go x squared minus 6x minus 7x plus 45 is equal to 0. So on the left hand side I can take a common factor out of x, and I'm left with x minus 6. On the right hand side I can take a factor out from as 7, and then x. Now this sign has to change if I multiply this out. I have to get 7x plus 45, so 7 times x is 7x minus 7 times minus 6 is 45. So if I multiply this out, I'll get back here. So I have not changed anything from my original equation. So equals to 0. Remember, we're working with an equation, not just an expression this time. So over here again I've got a common factor, x minus 6, my common factor in both terms, and I can take it out as a common factor. So I take out x minus 6 and I'm left with x minus 7. Now there are a lot of methods of factorization. This is my method that I use. You're welcome to use it. You can also look up any other methods that might be easier for you. Okay, so now my equation is in the form a times b times b is equal to 0. Can you see we've got it in the same form? So we can say our answers are as follows. If a is equal to 0, or if b equals to 0. So do you notice that we actually have two answers here? This is going to make sense when we work with the parabola. Right now it might make very little sense. So let's see. If a is 0, that means that x minus 6 is equal to 0. So x is equal to 6. Or it's possible that b is equal to 0 to make this equation true. So b is equal to 0, b is x minus 7, so x minus 7 is equal to 0, x is equal to 7. Okay, Now because either one of these has to be true for this to be 0, what you can write is x is equal to 6 or 7. And that would be your final answer.